So we're going to try video 1 here. We're going into part 3. So I again put the outline for part 3 up so that way you guys can kind of follow along. I did have to revise from our original information on the syllabus. We're going to eliminate unemployment entirely, and we're going to kind of bump inflation up as kind of our intro to the money market. I think that might be a little bit easier of a topic to start these videos with. So if there is any kind of technical issues or any difficulties or challenges, we can take care of them on a little bit more of the easier stuff than when we get to the more complex stuff. So that's where we're going to start. We are going to start by looking at inflation. And just like we started part 1 and we started part 2, I would imagine that some of the intro to this is, hopefully is at least some review from your Econ 1900 class. And for some of you it might be new, some of you it might be review, some of you it'll be a mix, but it won't be very long before we start getting into all brand new material. So I thought we would just kind of start out with our base definition for inflation. Inflation refers to the general increase in the level of prices. Inflation refers to the general increase in the level of prices. So one thing to kind of take away from that is that when we start talking about inflation and we start talking about an inflation rate, we are looking kind of in mass or overall in society. That's kind of what we mean by level of price, if you will. If we have an inflation rate, say, of 5%, it does not mean that everything in the country has gone up 5%. Some things went up 8%, some things went up 10%, some things went down 3%, some things didn't change at all. But overall, the price of goods and services that are purchased is 5% higher. So maybe average is kind of the wrong word, but it's kind of like a messy average. That's kind of what we're referring to when we talk about inflation. So as we kind of put together this, what we need to do is come up with a way of tracking those prices. And if it is something that is a price level, it's going to be really challenging to get the price of every single product all over the country that is sold constantly. So instead we use what we call price indexes. A price index is more of just kind of a measure of tracking prices in general using specific sets of goods. And we kind of think that from that set of goods, we can then kind of extrapolate some results for society. There are so many price indexes. There's really obscure ones and really common ones. So we're only going to really touch the surface of price indexes in society. There's a couple that the media uses quite a bit, and so I thought we would start with those as maybe a little bit of an easier method of kind of learning about these. So our two, big popular, our two big popular price indexes that the media uses are the GDP Deflator and the CPI. So we'll talk about the deflator first. This is the one that probably I guess both of them you probably got a little bit of exposure to in your 1900 class. But this one, a lot of times I know in my 1900 class, we tie it to nominal and real GDP, so we can kind of talk about it relatively early. Maybe one of the first kind of indexes that we look at. So that's what we're going to start with. The GDP deflator is a measure of the price level found as the ratio between nominal and real GDP. Again, a measure of the price level found as the ratio between nominal and real GDP. So kind of just a little flashback, if you can. When we talked about nominal and real GDP, we had prices, right? We had nominal GDP was effectively, year 1, 2, 3, and it was the price in year 1 times the quantity in year 1, the price in year 2 times the quantity in year 2, price in year 3 times the quantity in year 3, right, and so on and so forth. So we know with nominal GDP, price is actually a component. The same thing was true with real GDP. right? When we looked at real GDP, we had some constant price that we used. You know, if it was, if we made year 2 the base year, for example, we would say the price in year 2 times the quantity in year 1, price in 2 times quantity in 1. And again, remember, base year, you're going to get the same answer. So we have the same formula. And then down here, we had the price in year 2 times the quantity in year 3. Right, so we have our price and quantities, you know, kind of meshed up. So in one instance, we have price changing. In one instance, we have price not changing, right? And that was kind of the whole reason why we switched to real GDP. The GDP deflator effectively says you can work backwards, right? If we're multiplying here, we can look at division to kind of work backwards. So we can actually solve out the GDP deflator by looking at that ratio. That ratio means division of nominal, to real. So I would take my value for nominal GDP, divide it by my value for real GDP, and then I'm going to multiply by 100. This multiply by 100, I know it, you know, every time we kind of have done that, we've really wanted to look at like rate of change. We're not actually doing that yet. They want to index these values. They effectively want to scale them. So we could say that prices in some year are some percent of another year. So while it is still turning it into a percent, we're not looking at rate of change. We actually don't write deflator numbers with a percent on them. So I had a chart kind of pre-made here, just, you know, again, silly like little values. So, and I'll give you a second to get this in your notes as I get it all up here. So I'll have 3 years, values for nominal, and values for real. And let's see, what did I make up here? So I'll get out of the way and give you a moment to get that down in your notes. A couple of things to kind of think about. Again, just to kind of refresh your memory on. Right away, we know that year 1 in this example is the base year because nominal and real are the same. We also know that production is identical in years 1 and 2. Because real GDP is the same. So just again, those are things we already learned. We should know those. But because you can see that nominal GDP went up in year 2 and didn't go up in year 2 in real GDP, this indicates that the price level rose. Again, if you think back early in the semester to your charts when we were making real and nominal GDP, that was kind of our quote unquote the problem at the time, is nominal GDP was effectively capturing that inflation. Well, I want to make a new category here now for deflator. And all we're going to do is apply this formula to each of the year values. So for example, in the first year here, I'm going to put nominal 3,600 over real 3,600. That equals 1, so times 100. Maybe I should make that a little bit bigger. So just like what we saw for the CPI, for kind of some base year rules when we were doing nominal and real GDP, we kind of have a base year rule here as well. In the base year, our deflator value is always going to be 100. Mathematically, that kind of has to be true. Okay, so let's go ahead and apply this formula to my other years here. So I would take my nominal in year 2 of 4440 over my real 3600. I'm going to multiply that by 100. That's going to give me 1.23. So times 100 gives me 123.33. And then just to finish out the chart right here, I would take 7470 over 5100 times 100, and that's going to give me a deflator value of 146.47. So what do these mean? Well, like I said, what effectively these index numbers mean are, if I were to kind of translate this into words, it would translate into prices in year 2 are 123% of what they were in the base year. Kind of the same thing down here. Prices in year 3 are 146% of what they were in the base year. So kind of that's our basic, way of looking at and calculating out the GDP deflator. So the GDP deflator has some pluses and minuses with it. So first of all, I think it's pretty easy to calculate. We've already learned how to do real and nominal GDP. Once we have those values, which are readily available online easily for us on that Fred site, once we have those values, it's really easy to calculate. This is also something that is going to be utilized a lot in business. I think that, kind of that idea of GDP is something that is important to companies and the government. So a lot of times they kind of default to this one because it is tracking that idea of companies and ideas of government. There are some drawbacks to the GDP deflator though, however. First of all, I don't know if it pertains to you, my empty classroom, to you guys as students, because, well, keep in mind what's going into this value for GDP. Well, all components of GDP, like the investment component. So if a company builds a brand new factory and then puts a whole bunch of new machinery in there, that's going to increase investment, which is going to increase GDP, and it's going to effectively capture the price of that factory in any inflation rate. I don't think many of you are going to be buying any factories or assembly lines or whatever anytime soon, so do you really care about price fluctuation there? It also captures kind of the government spending component as well. The government might go out and they're going to spend, right now I think they just approved $7.5 billion or something on new testing for our coronavirus outbreak. While the testing may be important to you as students, the price of that probably isn't. And that price, that increase in that price that the government is paying is now captured in the inflation rate using the GDP deflator. So it seems to include a lot of things that maybe your average person isn't really going to, I guess, care too much about in their prices. It also is going to leave some things out that I think you guys as consumers might really care about. Like, in order to get to either of these nominal or real GDP values, it had to match our GDP definition, which meant new production within borders. Do you guys ever buy anything used? Probably. Do you ever buy anything that was produced out of the borders, like imports? Definitely. Are any of those prices going to be captured in the GDP deflator? No. They can't because they're not part of GDP. So we need another one that's going to be something that can tie to maybe consumers a little bit more. Enter the Consumer Price Index, or CPI. CPI, Consumer Price Index. Anytime you watch anything on the news, the media, whatever that is like reporting an inflation rate, because they're reporting it to you, consumers, I would all but guarantee they're going to use this Consumer Price Index. So let me give you a quick definition for that. The CPI is the measure of price level using goods that a typical consumer, the measure of price level using goods that a typical consumer would buy in a given period of time. So if we kind of break that down, first of all, given period of time, because that's the easiest part of the breakdown, they usually track this monthly, but you can also find it quarterly. They'll do monthly and quarterly, even though for us, a lot of times, if you remember like our data stuff, we did it annually. We did that for simplicity. Usually they're going to track it a little bit more rapidly than annually, but you can do annually as well. So that's kind of our given period of time. So goods that a typical consumer would buy. That's maybe a little bit tricky because what is a typical consumer buying? We have what we call a quote-unquote basket of goods. So we say, okay, your average consumer is going to go and buy this much in, this many food items. They're going to spend this much in gas. They're going to spend this much on housing. They're going to spend this much on entertainment. And then we kind of try to break that down into what goods are they purchasing. So we have this kind of a laundry list of basket of goods that are bought by consumers. It's these goods that we track in terms of test pricing. It's, I don't remember the exact number. Something like 1,500 goods make up a basket. I think it's just under that. I think it's 1,400. But whatever, I don't remember the exact number. And then they track those prices every month. So hypothetically, if I were to say, okay, so-and-so invisible person, here's a list. I want you to write down everything that you buy this month and write down how much it cost. Then what I'm going to do is I'm going to take that list and I'm going to make that my base bundle. So whatever year that is, whatever month that is, whatever, that's going to be my base bundle of prices. Then I'm going to photocopy that list a whole bunch, and then I'm going to give it back to you on the first day of the next month and say, go buy all of this stuff again, and we're going to compare the difference in prices. And then I'm going to give it to you on the first day of the next month, and the next month, and the next month, and we're just going to assume you buy that same basket of goods every month for a year. They actually do 2 years. They change the basket out every 2 years. So we're going to kind of assume you buy that same basket of goods over and over and over and over. From that, then, we're able to kind of come up with a formula, if you will. Just like we did with our deflator here, where we were using effectively a ratio, we're going to do the same thing with our CPI. We're going to effectively use a ratio. Mathematically, what I would do is take those current prices. Current prices means the first of every month. Every time you give me a new paper, that's our current price. And we're going to divide that by that base price. So that very first month that we built our basket and established everything. And then it is an index value, so we're going to take it times 100. So I know I actually got some actual values somewhere, if I can find where I grabbed them. So I'll do a quick example here. Like I said, I had some actual values. There we go. So I went and found these are actual values for the United States at kind of some annualized base. So same thing, I would have year 1, 2, 3, and 4. And then I would have some measure for price in here. I guess I can't quite read them, but that's all right. Here, we'll do this. So let's hypothetically say that we had year 1, we'll make our base year, and our price in year 1 was $500. Kind of the same rule here in the base year, because this is both our, because this is both our base price and our current price, we would mathematically be able to find out the CPI by taking 500 over 500 times 100. Gives me a value of 100. Right? And again, same thing that you notice with the deflator, that in the base year, I'm going to have an index value of 100. Okay, so then let's say that we're in that second month, second year, whatever it is, and I've given you the piece of paper, and you've gone and you've priced everything out, and then our current price in year 2 is 600. I'll only do 3 years here. In this case, now I would take my current price, 600, divide it by my base price right up here, 500, times 100 is going to give me a value of 120. Translation works the exact same way as it did with our GDP deflator. Our GDP deflator is saying that prices were this percent compared to the base year. Same thing here for our CPI. We're saying that in year 2, prices are 120% of what they were in year 1. And then if we hypothetically in year 3, let's say that I gave you the list, you brought it all back, and we got 475. Okay, I would do the same thing here. I would take my 475, put it over 500, and I would get 95 for my CPI value. And again, that's saying that in year 3 here, prices are 95% of what they were in the base year.